And the first important concept is the sample space. So what is sample space? And we have that the sample space is the set of all the possible results of a probability experiment. So sample space is the set of all the possible results of a probability experiment. When you toss a coin, for example, there are two possible results or two possible outcomes. The first outcome is head. The second possible outcome is tail. Then the sample space of tossing a coin once is basically h, t. That means one head, one tail. So there are two possible outcomes. One outcome is the head, the other outcome is a tail. So this is the sample space of tossing a coin once. So, for example, what is the sample space for a coin that is flipped 3 times? We can use to find the sample space what we call a tree diagram. And we have one coin, and we're going to toss the coin 3 times. And the first time that I toss the coin, I have 2 chances, or I have 2 possible outcomes. The first outcome is to get, as a result of tossing the coin, just to find that we get head or that we get tail. So you have 2 possible outcomes, head or tail. Now, when you toss the coin a second time, you again have 2 outcomes, head or tail. But now putting together the first 2 times that you toss a coin, you can have that the first time it was head and the second time it was head, or the first time it was head and the second time was tail, or the first time was tail and the second time was head, or the first time was tail and the second time was tail. But you have still to toss the coin one more time, and then again you have 2 possible outcomes, head or tail. So now you can just get that the first time was head, the second time was head, and the third time was head. So your outcomes are head, 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 h, 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 or the first time was head, the second time was head, while the third time was tail. So you got the outcomes h, h, t. Or you can have head, tail, head, or you can have head, tail, tail, or you could have tail, head, head, or tail, head, tail, or tail, tail, head, or tail, tail, and tail. So that's why when you see now what is your sample space, in your sample space you have 8 different outcomes, that you obtain from the tree diagram that we construct in this part. Now, we can also do this to identify the sample space of the probability experiment that is determining the children gender for a family of 3 children. We're going to use boy or girls. And it's pretty similar to the previous example, because when we have your first child, this first child can be either boy or girl. So when you have your second child, there are 2 possible outcomes for the sex of this child, that is just boy or girl. And also when you have your third child, then you have the same two possible outcomes that just be void or girl, and then you get these 8 possible outcomes in your sample space that are just having 3 voids, having boy, boy, and girl, or boy, girl, boy, or boy, girl, girl, or girl, boy, boy, or girl, boy, girl, or girl, girl, boy, or girl, girl, girl. So you can have, these 8 possible outcomes. The tree diagram is a tool that is really very helpful. So now you can say that your sample space is just this. So your sample space is made up by 8 different outcomes, and here you have the 8 outcomes, right, that we got from the tree diagram. Well, we have now, for example, another case that is find the sample space of the project experiment, record the day of the week, and whether it rains or not in that day. So you have in this case, 7 days of the week, and then if it's raining or not, so you will get, in this case, 14 different outcomes. So it's a 8 that is not correct. These are 14 different outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You can also find the sample space when you roll 2 dice in a poker dice game. Okay. So a die for this game has 6 faces. Are the ace, the king, the queen, the 7, the 8, the jack. And you roll 2 dice, the possible outcomes are these 36 results. So you can have first ace, and the second die is also an ace, or the first die an ace and the second a king, or the first die an ace and the second a queen, or the first die is an 8 and the second a jack, or the first die is an 8 and the second an 8, or the first die is an ace and the second a 7, and then like that it start again. Now the first die a king and the second an ace, and like that. So you will get a total of 36 results. As you can see, some of the results are repeated, right? Like, for example, this AK with one here that is KA. But they are repeated, so they are the same only if the order doesn't matter. If the order doesn't matter, right? If the order matters, then they are not repeated, really. So you have, for example, ace in the first die and king in the second die, and king in the first and ace in the second, or queen with an 8 in the first and 8 with a queen in the second, not like that. So you can consider that some of the results are the same if the order doesn't matter, or they are different if the order matters.